Welcome back, scholars, to our next video in our probability installment on conditional probability. So this is something that we started talking about in the last lesson with the difference between independent and dependent events, and we're going to pick up where we left off. So learning to comprehend that the notation, the probability of A and B is equal to the probability of A given that B must occur times the probability of B can be used to find the conditional probability for events A and B. So I can use conditional probability to justify that events are dependent or independent. I'll know I've got it when I can estimate probabilities, including conditional probabilities from two-way tables. So in case you didn't know, a deck of cards has 4 suits: spades, hearts, diamonds, and clubs, with 13 cards in each suit, for a total of 52 cards. Hearts and diamonds are always considered red cards, while clubs and spades are always considered black cards. And face cards are the jack, the queen, and the king. So conditional probability is defined as the probability of an event happening under the condition that another event occurs. Right, so the notation here is the probability the card is a heart, given that the card is a queen. So we have some probabilities to kind of look through, right? If we have a card that is a queen, and we wanted to know that what the probability of the queen, if the queen is a heart, there is only one possible way of doing that, right? The question becomes, out of how many possibilities? Is it 52? Is it 4? Is it 2? You decide and let me know. I would probably think bigger here, because our next scenario is the probability of the card being a heart. And then in the third scenario, the probability the card is a queen and a heart, right? So start with a bigger lens and then slowly whittle it down to a much finer perspective. Lana pulls out only the hearts from the deck and sets the rest of the cards aside. So that means that there's 13 cards remaining. She shuffles the hearts and draws one card. What is the probability she gets a queen? Right, so we're looking basically in only the second row of this visual that I have here on the left-hand side. Here, notices that the probabilities from the warm-up can be arranged into at least 2 equations, right? If we have the probability that the card is a queen and a heart, we can rewrite that as the probability that the card is a queen, given the fact that the card is a heart, and the probability that the card is a heart, right? So the reason why we can say that is because the probability that the card is a queen, given the fact that it's a heart, means that there's one queen out of 13 hearts. So if you had that one row in the previous slide, go back. And the probability of the card being a heart, there's 13 heart cards in a deck out of 52 total cards. So Kieran's wondering if it's always true that the probability of A and B is equivalent to the probability of A given that B times the probability of B for events A and B. He wants to check additional examples from drawing a card from a deck. So if event A is the card is black and event B is the card is a king, does the equation hold? Explain or show your reasoning. And if event A is the card is a face card and event B is the card is a spade, does the equation hold? Explain your reasoning. So you might want to actually type out those scenarios the way we kind of have this structure up here, and then accordingly determine what the probabilities are for each of those events. So here we have a coin being flipped and a standard number cube being rolled. Let A represent the event the coin lands showing heads, and B represent the standard number cube lands showing 4. Are events A and B independent or dependent? Remember, 2 events are considered independent if the likelihood of one has no bearing or effect on the probability of the other event occurring. So in this case, regardless of what the coin flip has no bearing on the dice roll. So that should kind of tell you whether or not the events are independent or dependent. And make your way through these accordingly. In these scenarios here, right, the probability of A given that B you might want to write out the full full notation to kind of help you with that solution path. And we have our summary here. So we'll pick up together in class. The only way that we have fruitful conversations is if you productively put together some numerical values. That way we can hammer out and make sure that there are no weaknesses. So please do your due diligence and handle your end of the bargain.